too radio loud to be stars, and they were too point-like and luminosities too in the nucleus of them to be normal galaxies. So it's like, what are these? Is the question here, you know? Um, so the remarkable properties of quasars soon led to more efficient ways of discovering them. Once you know what you're looking for, though, just like Sherlock Holmes, it's easier, you know? Like, once you start looking for these crazy things, maybe you'll find more, and maybe then you start to characterize them and you figure out, oh, so this is what we're looking for. Hi, Suji Mama. She's like right below me. She comes around and brushes against me to let me know that she's here. She's very subtle, kind of like quasars. But basically, once you know that there is a quasar, once you know what you're kind of looking for in terms of the properties, even though they're weird and you're unable to easily categorize them as either a star or a galaxy, but you can say, oh no, this is what we are looking for. It's this crazy thing that is, you know, kind of like really far away, kind of really point-like, lots of luminosity in the center. We thought it was a star, but maybe not. Then you can maybe find more. So for example, quasars are very blue compared to stars. So searches for objects with ultraviolet excess, you know, you can just say, look for objects with ultraviolet excess relative to starlight, of course, proved to be especially effective. So when you do that, you find more and more of this crazy object. Moreover, it quickly became apparent that there was an even larger population of objects that had the optical properties of quasars but were weak or even undetectable emitters at radio wavelengths. So as I was saying, we found those radio loud quasars first, but those are actually the more rare type of quasars. But because of the sort of how weird they were, they stood out, and we delved into it deeper, and we tried to find more of these things with ultraviolet excess, and we found more. But these were actually, what we found more of were actually the more radio quiet ones, the more where we see them in optical or other wavelengths. So these radio quiet sources became known as quasi-stellar objects. Also, you know, we're still on quasars, or simply QSOs. The original radio loud quasars actually make up only 5% of the total population of quasars. So this is what I was saying when I got started with the topic, which is that sometimes you find something really crazy and it's actually the more rare type of that thing, but the ridiculousness of it, or the interesting properties of it, gives it away, you know, and helps you to discover it. But don't expect to keep discovering only that kind of that thing. What we found more of is actually the more radio quiet quasars. Isn't that interesting? Intensive searches for quasars turned up yet another variant of the Aegean theme, objects that are known as BL-lac objects. Unlike Seyfert galaxies, which are named after their discoverer, BL-lac objects are named after their archetype, BL-Lacarte. The name BL-Lacarte is the type of name, 2 letters plus the Latin genitive form of the constellation name that is given to a variable star. So we also talked about pulsating variable stars the other day. So hopefully that live can help you with some more examples of variable stars. But in fact, BL-Lacarte was originally thought to be a variable star within our own galaxy. However, deep exposures revealed that BL-Lacarte is not a star but a distant elliptical galaxy. Its redshift is 0.07, puts it at a distance of around 300 megaparsecs, so closer than that first quasar. The reason why BL-Lacarte was originally mistaken for a star was that its unresolved nucleus is brighter than the diffuse fuzz of starlight surrounding it. So it's like really, really bright center and diffuse fuzz. The nuclei of BL-Lac objects are rapidly variable and have a non-thermal spectrum, but do not show any emission lines. This makes it difficult to determine the distance to a BL-Lac object unless you can manage to detect the absorption lines in the fuzz of starlight. Doing so is very difficult for many BL-Lac objects since their nuclei are so extraordinarily luminous compared to their stars. It also makes it difficult to determine their morphology. It's conjectured